Balancing chemical equations is essential because it adheres to the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. This fundamental principle means that the number of atoms of each element must be identical on both sides of the equation. Let's consider an unbalanced chemical equation. Hydrogen plus oxygen yields water. When we count the atoms on each side, we find that the reactants have 2 hydrogen atoms and 2 oxygen atoms, while the products have 2 hydrogen atoms but only 1 oxygen atom. This violates the law of conservation of mass. The equation is not balanced because the number of oxygen atoms doesn't match. The algebraic method offers a systematic approach to balance chemical equations, especially useful for complex reactions where trial and error becomes inefficient. Start by assigning variables like A, B, and C as coefficients to each reactant and product in the unbalanced equation. For each element, create an algebraic equation that equates the number of atoms on the reactant side to the number on the product side. To solve this system of equations, we typically set one coefficient to 1 as a reference point. From our hydrogen equation, if A equals 1, then C also equals 1. From our oxygen equation, 2B equals C, which is 1, so B equals 1/2. Since we have a fraction, we multiply all coefficients by a common factor, in this case 2, to get whole numbers. This gives us our balanced equation. 2H2 plus 1O2 yields 2H2O. We can verify that both sides now have 4 hydrogen atoms and 2 oxygen atoms, satisfying the law of conservation of mass. The algebraic method provides several advantages. It offers a systematic approach for complex equations, eliminates the guesswork of trial and error, translates chemistry into mathematical equations, and forms the foundation for computer-based balancing tools. The algebraic method continues to evolve with ongoing research refining mathematical approaches using linear algebra and programming, enhancing software tools for automated balancing of chemical equations.